Hi, my name is Darshan and I'm an online tutor of math and physics. In this video, we're going to talk about optimization related questions. We have already introduced optimization, but obviously it will make sense about relating the theory with the question. So, like I said, there will be a condition and there will be an optimization function. Let's try to locate both of them in this question. Find two positive real numbers x and y such that they add to 180. Condition that x plus y is 120. This is a condition over here. And x square y is as large as possible. We got to optimize x square y over here. So optimization function is going to be x square y. This is the optimization function which we need to differentiate and get the critical points. But I cannot really do that because I have x and y. I only need x. I cannot really differentiate with the y over there, and that's why the condition is given so that you can isolate y in terms of x and plug it in over here. So this is going to look like y is equal to 120 minus x, which we're going to plug it in over here. So this is going to look like f is equal to x squared times 120 minus x, which is equal to 120 x squared minus x cubed. This is going to be the function, and all you have to do is find the derivative. So f prime x is going to be 240x minus 3x squared. Then I gotta put equate to 0 to find the critical points because it cannot be infinity. So the critical points are going to be okay. 240x minus 3x squared is equal to 0, which means that 3x times 8 minus x is equal to 0, which means that x is equal to 0 or x is equal to 8. But I'm interested in the maxima, local maxima. So this is 0 over here, this is 8 over here, and I'm looking for a sign change. So if I put anything greater than 8, maybe 10, so this will become negative. Between 0 and maybe 1, this will become positive, and this will again become negative. We're looking for global local max, so this is a min because that's negative to positive, so this is what we are looking for. So this is a maxima over here. So they need two numbers which give that. So I already have the value of x as 8. This is one of the number, and the value of y is just going to be from here 120 minus 8. 120 minus 8 is 112. So these are two numbers which will add up to 120, and x square y is actually going to be as large as possible. So that is the solution of this. Hope this makes sense. The next question which we have over here is related to the volume. It says that the volume of the cylinder equals to V. So that's a condition, right? What is the volume of the cylinder, by the way? Pi r square h, that is equal to V. And they are saying that what proportion of the cylinder will minimize the total surface area. So we've got to optimize the total surface area, and the total surface area function is given by 2 pi r h plus r. I need to optimize, I need to minimize that. Obviously I cannot afford to have two variables over here, so I need to get rid of this h. If I need to get rid of this h, I can h or r, but I would prefer to get rid of this h because there is only one h. So from the condition, h is equal to v over pi r square. V is a constant because that's given to us. So the function is going to look like 2 pi r, and h is v over pi r square plus r. So this will be equal to 2 pi r, and the denominator we have pi r square, and here we have v plus pi r cube. Okay, in fact, let's not, let's not take the LCM. I'm just going to distribute. 2 pi r when multiplied with v over pi r square is going to look like 2 pi r times v over pi r square plus 2 pi r times r, which is 2 pi r square. Pi and pi is gone, so it will become 2v over r, because r over r square is just 1 over r, and this is 2 pi r square over here. Okay, so this is going to look like the function is 2v times r raised to minus 1 plus 2 pi r square. Let's find f prime. So that's going to be minus 2v r raised to minus 2 plus 4 pi r over here. F prime should be 0, which means that 4 pi r minus 2v r raised to minus 2 is 0, which means that 4 pi r should be equal to 2v r raised to minus 2, which means that 4 pi r is equal to 2v over r square. Too many steps. I'm going to multiply both sides with r square, so 4 pi r cube is equal to 2v. Oh my goodness. Let's clear this up. Okay. Which means that r cube is equal to 2v over 4 pi. And what do we have to find? Proportions of the cylinder. So basically they're looking for the ratio of r and h, I think. Yeah, r and h. So the value of r cube, or r, comes out as v over 2 pi raised to 1 over 3. That is the value of the radius. But they are looking for proportions, so I need to find the value of r and h. In fact, you know what? I'm not going to do that. Or there's even a better way to do this from here right away. Okay, and notice what v is. V is pi r square. So I'm just gonna first write it as v over 2 pi, and I'm just gonna replace v with pi r square h, because I can do that, right? Volume is pi r square h. Pi and pi is gone. R square, dividing both sides with r square, so this becomes r is equal to h over 2, and there you go. It means that r over h dividing both sides with h is 1 over 2. This is the final answer. It was a tricky one, definitely, but I hope this makes sense now. I think we're going to continue the remaining questions in the next video. I'll see you there. Bye-bye.